Friends, today we are going to discuss about important topics of physical chemistry for M.Sc entrance examination of Indian universities. So first topic is from gaseous state. In this we have to study about ideal gas laws based on kinetic theory, behavior of real gases like the van der Waals equation, and critical phenomena, that is critical temperature, critical pressure and critical volume. The next topic is quantum mechanics, in which we have to study about Schrodinger wave equation, eigenfunctions and eigenvalues and quantum mechanical operators. And next, orthogonality of wave functions and the particle in one-dimensional box problem, like the probability of finding the particle in one-dimensional box, the energy of particle in one-dimensional box, and the boundary value problems. And the next topic is molecular spectroscopy, in which we have to study about region of electromagnetic spectrum, emission and absorption spectra. This is very important topic in view of examinations and it comes in almost all the examinations. The next is selection rule, the diatomic molecules, rigid rotor and non-rigid rotors. The next, vibrational rotational spectra of diatomic molecules, very important. Harmonic oscillator, rigid rotor approximation and anharmonicity, Frank-Condon principle. Frank-Condon principle is important topic in view of examinations and you have to get it. The next topic is from the thermodynamics, and in that topic the first law of thermodynamics we have to study about the sign convention for heat and work, nature of work. Sign convention means positive and negative heat and work in various examples, and the part dependence of heat and work, heat capacities Cp and Cv and their relationship for ideal gases, the internal energy delta U and enthalpy delta H for chemical reactions. The next is Kirchhoff equations. And from the second law of thermodynamics we have to study for the Carnot cycle, entropy, very important topic. Don't forget to study entropy changes in the reversible and irreversible processes of the universe, and entropy of an ideal gas, entropy changes in mixture of gases, Joule-Thomson effect, Joule-Thomson coefficient of real gases. Just study about the main points of the Joule-Thomson effect and Joule-Thomson coefficient of real gases. And the next is inversion temperature, free energy and its concept, Gibbs and Helmholtz energy, variation of free energy in equilibrium constant, Maxwell's relation, Gibbs Helmholtz equations. The topic marked in red is very important and don't leave it. It is asked in almost all the examinations, so be ready for that topic. And the next is criteria for reversible and irreversible process, free energy, partial molar quantities, very important topic, chemical potential, very important topic. The Gibbs-Duhem equation, a very easy one but get it remembered. The determination of partial molar quantities, chemical potential in case of a system of ideal gases. And the next is from the statistical thermodynamics, the Boltzmann distribution, Maxwell distribution, very important, thermodynamic quantities from partition function, the Maxwell-Boltzmann statistics, Fermi-Dirac statistics, Bose-Einstein statistics. And next is thermodynamics of solutions, in which we have to study about fugacity, variation of fugacity with temperature and pressure, Henry and Raoult's law, very important, thermodynamics of colligative properties, in which we have to study about depression of freezing point, elevation of boiling point, osmotic pressure. And the next is Van 't Hoff equation, very important in view of examinations for entrances, measurement of osmotic pressure and determination of molecular weight of macromolecules. And next we have to study about the electrochemistry, in which we have to study Arrhenius theory of electrolytic dissociation, very important, Arrhenius theory, don't leave it. Hydrolysis of salt, that is also very important topic, don't leave it. Transport number, very important, almost asked in each year, and its determination by Hittorf methods. The next is Khola's law of independent migration of ions, determination of degree of dissociation and dissociation constant of weak electrolytes and acids. Degree of dissociation is very important topic, don't leave it. And next is electrochemical cells, in which we have to study about free energy and EMF of reversible cell, Nernst equation, very important, don't leave it. Without it you cannot solve the electrochemical cells problems. And next is standard electrode potential, reference electrodes, determination of ionic activities, pH and equilibrium constant, very important. pH questions are asked every year in almost all the Indian universities. Concentration cells with and without transference, liquid junction potential, And next is topic which we have to study is electrochemistry, in which we have to study about Debye-Huckel theory, Debye-Huckel limiting law for activity coefficients of ion electrolyte solution and its modification for concentrated solutions. The next is nuclear chemistry. In this we have to study about decays, types of nuclear reactions and the decay constant, very important. Every year questions are asked from these topics. Half life, very important, don't leave it. Mean life period, nuclear fission and fission energy. And next is phase equilibria, in which we have to study about Clapeyron-Clausius equation, phase rule, phase component, degree of freedom. Degree of freedom is very important topic, so don't leave it. And next is phase diagram of one component system like water and sulfur system, two component system like phenol water and lead silver, etc. And the next topic is from chemical kinetics. See, we have marked read all the topics, and all the topics are very important of the chemical kinetics. Don't leave it. And it is a scoring section in entrance examinations. In this we have to study about order and units of chemical reaction, pseudo order reactions, determination of rate constant and order of reaction from kinetic data, effect of temperature on rate of reaction. And next we have to study about collision theory of rates of biomolecular reaction and its comparison with Arrhenius equation. And complex reactions, in which we have to study about reversible, concurrent and conjugative reactions. Unimolecular gas reactions, in which we have to study about Lindemann theory, very important. And steady state approximations, a very important topic, so don't leave it my friends. Steady state approximations, it is very important in view of M.Sc entrance examinations. And next topic is from surface and photochemistry, in which we have to study about Gibbs adsorption isotherm, multilayer adsorption, BET equation, heterogeneous catalysis, kinetics of unimolecular surface reactions, inhibition and activation energy. All the topics are very important, don't leave it. And objective questions are asked from these topics very much. And next is kinetics of enzyme reactions, Macaulay-Menten equation, effect of temperature and pH, quantum efficiency, kinetics of photochemical reaction like HBr, HCl, HI, ethane, anthracene and acetaldehyde. Quantum efficiency is very important topic, and Macaulay-Menten equation is also very important topic, don't leave it. And this, so friends, these were the important topics of physical chemistry for M.Sc entrance. And remember one thing, that you have to not learn the derivation, just understand about the definitions, concept and finally derivative equations and the numerical problems based from all these topics, especially from the chemical kinetics, photochemistry and nuclear chemistry. Don't forget to solve the numerical problems of these three topics. These are very important topics and which are raised every year. Okay, thank you.